Over to you.
Going to give it a shot here. As Chris said, I'm Brian Toleson out of Southern California. I'm the president and chief engineer at Everfilt. A little about my background is 1988, I was going to Cal Poly Pomona getting my ag engineering degree. And the way I made a living while I was trying to raise a family was I had my contractor's license, so I was doing irrigation installation of systems. Turned out that the filtration equipment I was using happened to be Everfilt at the time. So I went on with that. In 1990, I got my ag engineering degree, and there was an ad in the IA paper about an applications engineer for Everfilt, and I applied and I got that job. So I started at the bottom, worked my way up to vice president, and then last year my son and I purchased the company, so now we're the owners. I kind of started one level below the post guy in the corporate level. I had to take it one level lower than that, just make it a little more difficult, I guess. But it seems like it's panned out, and we're having a pretty good time. So if you'll bear with me on this presentation, I haven't done this thing for like 10 years, so I'm a little out of practice, but hopefully I can prevent you guys from going to sleep and give you some good information, and I encourage questions. I've been designing filtration systems for over 26 years now, and we've done everything from filters for animal ponds, elephant ponds, to fountains for the Olympics and things like that, all kinds of agricultural golf course systems, everything from Dubai, Kuwait, Mexico, Peru, you name it. So it's been all over the map. So let me get going here, and hopefully I can give you guys some good information. The company was established in 1978 based on a wedge wire design, which is some stainless steel wedge wire, which isn't plastic. It has better characteristics for durability. And all of our systems are based on that design. I just wanted to give a little bit of illustration of what we deal with. You know, you guys are going to see different types of water. You're going to see algae. You're going to see everything. And when you're doing a filtration system, a lot of these different aspects come into play, you know, because you have to have not just what the water quality is at that particular time. Maybe it's 70 degrees out, nice day and all that. But the next day, maybe it's raining, maybe you have wind blowing. All those different things affect how you're selecting a filtration system. This is a picture of some of the smallest units that we manufacture. These two units right here will do about 40 gallons a minute. Those are 304 stainless. And then we do systems up to like this. You got a 7,000 gallon a minute system. Those are 72-inch tanks. The one right before that were 12-inch tanks. So just depending on what the capacity is, you know, we can do a system to do just about anything. And it's all basically the same operation. It's just that you're adding like modules just to expand. Okay. This one happens to be down in Irvine, California. This particular application is down in Imperial County, California, and you can see they've done some other little things like put these screens up here. It's like chicken wire or something like that, but people start getting a little fancy with ways to remove algae that's going to affect their backwashing and their filtration level. So it's kind of interesting to see what some of the people come up with. I had a guy down in Mexico one time call me up on a big system, and he's going, Brian, I don't know why these filters keep backwashing all the time. They were fine up until last week. And you know, so we went through a couple different things, and I told him to check some things, and they were coming out of a canal. And so he went back and checked these things, and he called me back a couple days later, and he's like, Brian, you're not going to believe what I found. What's that, Rick? And he said the suction line fell off of the refrigerator door. So I'm like, what's up with that? Well, what these guys had done is, since they're in Mexico and they're being resourceful, they had taken the suction line from the pump. They didn't have anything fancy to keep it out of the mud with, so they strapped it to an old refrigerator door and threw it in the canal. Well, finally, I guess this thing came loose, and so it was just sitting in the bottom of the canal, just sucking the mud right off of it. So once they strapped it back, away they went, and they were in good shape. This one here is kind of interesting, and I'll show you at the end of it, but see that white pipe right there? Let me see. This white pipe right here? Well, at the end of this, I'll show you what they're doing with that. There's all kinds of ways of settling and helping the filtration system out so you aren't continuously backwashing. Some people use reservoirs to allow settling. Temperature changes can affect that and get algae bloom. Those are more things that need to be taken into consideration when you're doing the filtration system, okay? This is another area. This is Imperial County again, and in the summertime or when they're irrigating, a lot of times they can get a lot of wind-blown dust that affects the load the filters are going to see when they're operating. Sometimes those canals might be running nice and clean. Other times there's a lot of wind-blown dust. You'll see tumbleweeds and that kind of thing in there. A lot of times when they start up, they'll have all this, there's just mud and everything along these sides of the canals and in the bottom. So if you're the unfortunate guy on the end of that and they start this thing up, you need water real bad, your filter's going to have a big load because it got the tail end of everything. And I'm sure some of you guys have been on that. These are some of the considerations when you're going to install a filter system. The site location to make sure all your piping is where you're going to want it to be. The one thing you have to look at is having it out of the way of all your equipment. The other is based on what size system you're going to need, how to get the concrete pad set up for that. Depending on the size of the system and the configuration, there's some charts that can be used to figure out the approximate slab slide or size that you need. You guys are using primarily up here in this area 2 and 3 tank systems, so they're fairly straightforward, and that's characteristic of different types or different parts of the country have different farm sizes and methods of farming. So up here they're smaller pads, but down in the southwest they get pretty extensive, because they're covering a lot of ground. It becomes more critical. This just gives more size, different configurations. This gives an example of a couple systems. This is coming out of the California Aqueduct. Whoop, hit the wrong button. This is coming out of the California Aqueduct. So there's 23 48-inch tanks, and it's doing this peach orchard behind there. This is another system down here. This is more of an industrial system, but it just shows some of the things that we get into. Actually, this one's for a packing house in Bakersfield where they're doing wash water. And I imagine it's going to be coming under some of these rules that they've been talking about previously. I didn't even know about this FSMA information until Mark sent me an email a couple months ago, so this is all new to me. I've learned a hell of a lot today just with what's coming up. It's been pretty informative. Here's some of the other systems that we do. They're just kind of configured for industrial or agricultural. It just depends on the application. We can suit each one for the applications. They can all be, this doesn't apply to you guys too much, but they can all be organized in different configurations, 2 tank, and then we just add 3 tanks to it. And then if we need double that, we can mirror image it and get 10 tanks, on and on. It's basically like a big Lego situation. Here's one of the projects we did down in Palm Springs area, and there's 28-inch, or actually 28 48-inch diameter tanks for a grape vineyard down there. And then down here, here's just a plan view, basically an overview of it. I'm just giving a few of the examples of what we do. This is a high pressure system, the yellow one. So you can see the shape of it. In order to handle the high pressure, we have to make the heads and jackets different configuration on them. So that's at a golf course actually down in Yuma, Arizona. So it's running at 175 pounds of pressure, which you guys won't see probably, but I think you're probably in a 30, 40, maybe 100 PSI once in a while range. But when they end up going to high pressure, they start looking a little different. This one on the right actually is for General Electric facility back in Cincinnati, Ohio, where they were testing jet engines. And it's a cooling tower filter for one of the systems. But they used to run the jet engines in these big rooms and had these devices that would hold them, and they could actually run the engines right there inside this building and do all the endurance testing on them. Now this just gives a little bit of what's in the tank. So there's basically just a couple of parts. The water enters here, passes down through the tank, hits this sand in here, which is a specific type and size of sand. The shape is actually angular to help with the filtration level. Then the water is collected in an underdrain system on the bottom, and the clean water exits the tank. Okay? Yeah, you got a question?
If sand is angular, how long is it good for?
Well, you know, a good rule of thumb is every year, if your backwash is set up correctly, you're going to lose maybe a ½ inch to an inch of sand. So you throw a little bit more in there. So you're going to continuously be replenishing that sand. So you're going to have new stuff and stuff that's a little worn out. But I really, honestly, haven't seen any ever wear out. And I know it's getting a little bit less angular as time goes by, but like I say, by the time you keep adding, I've never seen anybody just have to take it out and dump it because it wasn't filtering correctly, just from the shape.
What about when it starts turning orange from rust or something like that?
It shouldn't.
Not backwashing good enough?
Well, have a lot of iron.
Yeah.
Yeah. I mean, it shouldn't really affect the performance of the sand because it's just basically like glass. You know, that's all it is. Might not be backwash enough. Might stir it up. You know, sometimes if you don't have the backwash set correctly, then you won't blow that material out. So the backwash is one of the most important characteristics of setting up the filter correctly.
What do you typically figure for a particle size? How low can you go as far as microns with sand?
Well, you know, for irrigation, everybody's probably going to be in the 200 to 150 mesh, right? Mark, you guys? So we're going to be in that range. It doesn't make any sense for us to go down to 10 micron or anything like that because you're just going to be spinning your wheels. There's no sense. All the irrigation tape and sprinklers out there are designed to operate with a filtration level at that size, you know. So it'd be overkill for us to go anymore. We can get down to 5 micron with some of the other equipment we have. We basically just make them a lot taller and we use different types of filtration media in it. But it wouldn't be advantageous for you guys for irrigation to do that, you know.
But it can be done.
Oh, yeah, 5 micron.
Multimedia sand filter.
Yeah, we could do a lot of things like that. Yeah. So I mentioned that the water comes in through the side, goes down through the filter media, and the filter media actually is what cleans the water, and then the clean water is discharged out through the bottom. But there is a couple other pieces in there. One is there's a deflector plate in the top which prevents the water from just putting a hole right in the sand bed and trying to get right through the underdrain, okay? So that helps distribute the water evenly. The other component that's in there is the underdrain assembly, which has actually it has wedge wire, and I left that box. Is there a box? A white box? There's I had a couple of samples. Yeah. Here's some samples of wedge wire if you want to see what we're putting in there. You can just check them out. It's kind of interesting. Pass it around and check it out a little bit. It's not plastic, it's 304 stainless. It's got a burst strength of 1500 psi, so it's pretty, you could do just about anything to it and you aren't going to hurt it. Okay? But that's the material that we use in the underdrain, and the sand sits on top of it while the clean water is collected and passes through the slots in the screen. And then when we go into backwash where we have to clean the tank, then we reverse flow up through the screen, and that disperses the water out through the gravel pack, and that's how you get your backwash out of the filter system.
What's the purpose of the gravel?
The gravel, when the water's coming out through that screen, the gravel is sitting on top of the screen, and when the water flow comes out, it helps disperse that backwash water into a bigger pattern so you get better overlap.
So you said actually the filtration is 120 to 150 mesh. And so what size gravel are these guys typically want to use to reach that?
Well, we use the 3/4 inch gravel normally as the pack on top of the underdrain, and then number 16 silica sand will generally give you about 150 mesh, and number 20 silica sand will get you down to, well, it'll get you a little over 200 mesh.
So is this piece of metal, that's what's determining this size, or?
No, this is just, what this does is
That's
two,
the same regardless of what?
yeah.
What?
The sand in there is what's giving you your filtration level, okay? So you can adjust the size of the sand to the filtration level you need. The underdrain is there to retain the sand in the filter and to also distribute the backwash water when you go into backwash.
So
Okay.
when you're blowing out your sand, when you're losing sand in your filter, you're either underdrain broke or it's underdrain. You're the only reason way that sand's getting out. Right?
Yeah, either that or you're going to blow it out backwash, you're right. But I've only seen like 2 of these underdrains go bad from that wedge wire.
That's the only manufacturer of them. There's other guys out here that use a different type of underdrain that we don't see it so much in here. We see it in some of the other manufacturers where the underdrains actually are damaged.
Well, that's what I was going to say. I've seen this happen twice in ours, and I've been there 26 years. But what happened is we had a guy out in Hemet at a citrus orchard, and he had a filter go bad, and I was like, I just hadn't seen it. So we got it in there and cut it open, and what had happened is he hadn't backwashed these things. And I mean, he'd been running the hell out of them. So what happened is the sand bed got solidified, basically, and little channels formed through it to allow the water to pass. But the velocity of the water going through there was so high, it had sand right where the screen and the tube intersected down there, and the sand was just churning in there at a super high velocity, and it actually wore holes through that material. But it was kind of interesting. From an engineering standpoint, I was like, wow, that's crazy, because you always hear about the path of least resistance, and I mean, it was right where that screen and tube came together. Pretty interesting stuff, at least for me. I don't know, maybe you have.
So is the backwash something that should act, is it an automatic thing, or is there
Yeah.
pressure loss or something that?
Well,
triggers that, or is it?
there's a couple different ways of doing it. There's an automatic system which comes with a control. It'll have a time function on there, so you could put 3, 4, 8 hours on there, and it'll wait till the end of 8 hours, and it'll initiate a backwash cycle. The other part of that control system is a pressure differential switch that senses the pressure in between the inlet and the discharge. And there's a pointer in there. When it comes in contact with this pin, and it has to stay there for 15 seconds to make sure there's no false signals, it'll go ahead and start the backwash cycle for you. Okay? Yeah.
So if you're gonna treat the water for like an iron or something like that, you should treat it before the filter or after the filter?
Well, if you're gonna, I mean, if you can filter iron out, just the way,
If you're gonna do something to get it to drop or
I mean,
keep it in solution or something like
you know, the ones
that. He sells me.
The ones that I've seen, you know, the problems I've seen, go ahead, Mark.
Well, I think that's going to be addressed by Chris, because they approach the iron content, they approach it two different ways. One is to filter, to apply chemical and then remove it in a filter system. The other way is to apply chemical and keep it in solution and out to your drip tape.
Okay, that's what we're doing. So do we do that before or after the
Well,
filter?
that depends. So I think Chris might be able to address that now, but it depends on the level of iron in the water and how Veris or the other chemical companies want to approach it. Because they have two, as far as I know, they have two different ways that they can approach the iron in your water. One of them requires filtration before, the other one is after. Is that correct?
Yeah, that is absolutely correct. You can either transport it by basically using a molecule to bind up the iron, keep it in solution, make it go right up through your drip tape, in which case you're probably going to want to do that after your filtration. But also, we'll get into it in the presentation, when you start talking about little iron particulate, it can get awfully small. I mean, we're talking 5-10 micron range, so you got to have filtration that's able to handle, filter out those smallest particles, if that's what you're trying to do. Also, when you're in, say, half a part to 5 parts, it's a very different approach than when you get up to 7 and 10 and 15 parts of iron, like we sometimes see around here. The things that work at 5 parts, you can't just multiply it by 2 and have it still work when that's 10 parts of iron, unfortunately. But we'll get into that in some detail after lunch.
Yeah.
Is the gravel all one size or we're?
Well, I mean, it's 3/4 inch rock is usually what we put in there. Different people in different parts of the country might use pea gravel because they can't access 3/4 inch rock, but generally what it is we try to get crushed rock like concrete aggregate. You don't want any sandstone, you don't want any limestone, you don't want anything that's going to dissolve and, you know, and get stuck in the underdrain. So hard rock, crushed preferably is what we recommend for it, but it's all one size. When we do the industrial systems, then we go ahead and start putting gradations in there, like we'll use 3/4 inch rock and we'll use pea gravel on top of that to separate it. But then we're using multiple layers a lot of times. We might use garnet, we might use silica sand, and then we might use anthracite on top of that. And actually what we can do in those more precise levels of filtration is that we can stratify the bed and get different layers of filtration on each level, okay? Because each material has a different specific gravity, so it will actually stratify out into distinct layers. And then we can have a fine one on the bottom, a medium one in the center, and a coarse one on top. But for irrigation, you normally don't need that. You need to get to maybe 75 micron or so, 200 mesh maybe, and you're good to go. Any more than that's just going to cost you a ton of money, and you aren't going to see the benefit out of it, you know. Anybody else? Okay. I'm not sure if you guys are familiar with the actual filtration process or the backwash, but this is just kind of a quick run through. These things are operating in parallel. The water's flowing from top to bottom down through the filters, and then the clean water discharges out the bottom. When we go into backwash, we backwash one tank at a time. Okay, so if we had 2 tanks, this one here is going to be providing filtered water. So we're going to take the filtered water and bring it over here. We're going to change this valve position, which opens the top of this tank up to atmosphere basically. And when we open it to atmosphere, naturally the water wants to get out, so it has to go up through the filter to get out. Okay? Then when we want to do the other tank, we just reverse it. And that's all that's happening right there. So there's no big magic to these things. You know, when I have done these things, it's like people get intimidated sometimes because we'll get some systems that are pretty huge. But when they go into backwash, that's all we're doing is we're just creating an opening to atmosphere, and the water wants to escape, but we put it in a place so it has to go through and rinse that media backwards. Yeah, Mark?
One of the things that we encounter quite often is that people, in an effort to save money, they want to make that system as small as possible. So they don't realize that when they go into backwash, they just lost half their flow.
Right.
flows off to half. So
Right.
now they're in backwash for half of their irrigation cycle because they have dirty water.
Right.
But they're not getting all the water
Right.
to their fields. They don't understand what the reason is. And we can go back to the whole process of, well, this one's X amount of dollars and this one's X plus whatever. I mean, so
Yeah,
really
it's-
easy to let economics rule that decision. And in the end, you're just kind of shooting yourself in the foot.
Yeah, you know, let me get to one thing. I'll get to in just a second. But if you think about this, you guys, these filters say they've been running for 4 hours, and all of a sudden one's crying uncle, say I need to be backwash, right? So then you basically double the flow through the one that's going to provide the backwash water, and it's already really dirty to clean the other one. So the 2-tank thing it's a sensitive issue. The guys at Cal Poly San Luis Obispo and their irrigation work, they basically say stay away from 2-tank systems. It's a little more money to go with a 3-tank, but it's a lot easier to operate. You're going to get better results. It's going to be a lot more lenient to operate. You won't get yourself in trouble as much, you know. And if something changes, you're going to have a lot more flexibility with a 3-tank versus a 2-tank. Yeah, hands down. I've seen it happen a lot, and these guys, they'll be in a dirty water situation, and you know, the tanks are just overloaded with material, and then you try to backwash one, and sometimes they just give up. You know, they have to do something like hook a fire hose up to the bottom and come up backwards through them just to get them going again. So the 3-tank is really something to consider. You had a question?
So I have that clear tube on, I have one of your set filters.
Uh-huh.
And I have one of those, I have that clear tube that we can watch the water go through. And it seems like when I do a backwash, there's like 2 or 3 stages. It's like it comes clear, and then pretty soon it'll go real dirty, and then it'll go clear again. Is it going different ways through there, or
Yeah.
what's going on?
Let me get over here a little bit, and you'll see exactly why. Let me get through this. Here's a picture of a typical underdrain assembly that's in a tank, so you can see the screen on the end of them. Different size tanks have to have a different amount of screen. It's all based on the velocity so that we get the proper agitation of the sand. This is just an illustration of a pretty well thought out system, and I like to show it so people see what's involved in a properly designed system. These guys have their pump here. Some guys don't need to have this, but they have their priming pump. They have an air vent on the inlet line. They have their restrictor valve to control the backwash rate. They have a flow meter here, air vac line, and they also have a pressure relief valve in front of their butterfly valve. So if anybody goes up there and tries to shut something off, their pressure relief valve is going to take care of the system for them. So I just like to kind of show this, and people see some of the components that you really need to have in there, or that are always good to have. And this is just a breakdown on the pieces, basically, on what's involved in putting the system together. It's basically the tank and the backwash valve multiplied out on these things. So like Mark was talking about, if you had 3-tank, then you just take basically all the items right here and just set it over here again. And you just keep going right down the line. Okay? Now here's the backwash valve. And you mentioned that you see different stages in the water, right? You're 100% correct, and I'm glad you brought that up, because what happens is, if you look over here, this is the hydraulic actuator. So that black piece right there is it's a diaphragm, rolling diaphragm. So what happens is, we put water pressure into this area right here, and it pushes on this diaphragm. And as that happens, it starts moving this shaft over, and this plate is on the other end of the shaft, so this thing starts moving over. Okay? So as we put the Whoop, I got it. As we apply the pressure here, this whole shaft assembly starts moving through here. This is the backwash port. This plate right here starts sliding over. And it travels till it hits all the way on this end where it shuts the inlet off totally. But when it's traveling through here, the water can come right in the inlet manifold and go around this plate and out the backwash line. So when you start seeing your backwash, that's why you're seeing that clear water basically, because you're getting inlet water going around that plate until it's fully seated. Then when it starts getting really dirty, you'll see it change from clear and it'll go dirty, dirty, dirty until it's filthy. That means that this thing is finally moved over here and you're getting all the material coming straight up out of the tank at that point. It's not allowed to bypass that. And then you'll see it get clear, which means your filter's clear. And then it'll reverse. What'll happen is that water pressure out of that diaphragm area over there just gets released to atmosphere, and there's a spring in there that just pushes it back, and then it seals off. And it just waits until it gets more hydraulic pressure to repeat that process. That's the only thing that's happening there to make that backwash. Okay? These are just the components that are involved in the for the automation. It looks like a lot, but it's not really that much. Yeah?
How fast does that thing move? Is that based on pressure or?
Yeah, a little bit. And you know the filter that's in the end of the manifold, there's a little Y strainer in there. If it gets plugged up, it's going to take longer for that valve to move because the water's having a harder time getting through the filter. So make sure that filter's good and clean. But normally it takes about 25 to 30 seconds for it to move all the way across. That's normal. We don't want it to move too quick because then you can set up things like water hammer and are not good on your system. This basically shows though all the components that are involved. So on the inlet manifold, we take the pressure, run it through a filter, then we run it over to a solenoid valve, and the solenoid waits to get a signal to let that water into that top part of that valve like I was showing. And as long as the electricity is on that solenoid, it holds that valve open. As soon as we release the electricity, the solenoid changes position and it allows that water to vent out to atmosphere and the valve returns. So there's only two moving parts in one of those tanks. That's the solenoid plunger and that shaft assembly. That diaphragm that's in there that I was showing you is, it's rated for 1 million cycles, and it's rated at 300 PSI, so it's pretty durable, you know. It's a pretty unique part. I don't know, is that box, let me, Jeff, is there a diaphragm in there? It's kind of trippy. Nah, there's a solenoid, there's no diaphragm. Black rubber thing in there? No, okay. All right, I thought I brought diaphragm with me, but it's kind of interesting the way they're made because it just looks like a hat, an inverted hat, but it's kind of crazy because you can stretch the circumference back and forth this way and it'll give, but if you try to stretch it lengthwise, it won't move at all. So when you apply pressure to it, it expands against that housing wall, but then it also forces the piston. It's just the way they're made. And it's a pretty unique piece. But again, it's rated for 1 million cycles. So it'll last quite a while. Yeah?
I don't know, maybe other people aren't curious about this, but when I bought that, I tell you the truth, I didn't really trust it. So I put a screen on the outgoing side of it, a screen filter, just so I can check to make sure. And they do work. And, I get a little bit of iron buildup in that screen, but I've never had any sand or anything get there. So.
Well, you know what
anyway, I just, maybe other people don't trust it too, but it just didn't make sense to me that sand wasn't going to end up in my...
But see, that sand it's kind of a special sand because what they do is they grate it.
Yeah.
And that screen is set up so that the grate of sand won't pass through it, right? Yeah. But when they manufacture the sand, though, you're going to have some fines in there, you know, some undersized stuff. Some of it will go through that screen. But when I have people start these systems up, what I try to get them to do is have an isolation valve on the discharge side and shut that off, and then start up your system to backwash your sand initially, and just backwash the hell out of it till you know you got all the fines out. Then you can start running out in your system, and really you should flush your main line out at that point. But after you've got that set up, you should be just ready to go, you know.
Yeah, I just wasn't a believer, I guess.
Yeah, well, it's a new thing, you know, it's a new thing to certain people, but the technology and the methodology's been out there for centuries, man. A lot of the municipalities and things like that do the same thing, except a lot of times you'll see these big concrete pits, and that's their sand filter. It's just a super large one, you know. You can't beat it for durability and simplicity. I mean, there's not a whole lot going on. You don't have a moving part flying back and forth and one going this way. And you know, the beauty of this is, if you say you had 24-inch tanks, I don't know what you have, but you could plug them up till you had 100 PSI differential on them. You didn't do anything to them. You didn't damage them. There's a lot of tanks out there right now. You put a 15 PSI differential on them, you're going to buy new tanks, and they won't warranty them. There's 12.5 square feet of area on a 48-inch tank times 144, so I don't know what that gets you, but I just did a rough calculation, like 15,000 pounds of force on some of those underdrain designs that are different from ours. And I've personally seen them where they're reinforcing right through the bottom of them, and they're junk after that. So you can't hurt these. Might take you a while to clean them up if you did something really, really bad, but it should be fine. Okay, that does that. I'm not going to go through all this. I think I can give you an idea how these things are sized, but if you take one of these filters and you take the top of it off and you measured the square footage that's inside that tank, where the water's going to see the sand, every square foot is rated for a certain flow rate. So the maximum flow rate per square foot of that area on top is generally 25 gallons a square foot. And that's pretty decent clean water. But as you guys start getting into some canals or real silty rivers or streams that run brown a lot of the time, then you might want to take that 25 and you might want to take it down to 17 or 15 gallons per square foot, and it allows the filter to work a lot better. You won't get the top of the sand sealing off with certain materials, and it allows the water to penetrate the sand bed a lot better. So that's just something I want to throw out there, is how they're sized and how the loading on the filter gets affected, and you have to adjust the filtration rate on them. And I'm sure Mark and Jeff, they have a pretty good handle on the local conditions. Certain areas might allow you to run them higher, and certain areas are going to force you to run them lower to get the best results. So these guys are going to have the best handle on what suits each area. All right. And this just gives a little bit of information on some flow rates and operating pressure, sand and gravel. The one thing I didn't mention, though, just as you have the filtration rate going down in filtration per square foot, you also have a backwash rate. And what that is when the water comes up from the bottom, you need X amount of velocity to agitate that sand bed adequately and get all the particulate out. So that number is right about 15 gallons per square foot of filter area. So if you had a filter with 10 square feet of filter area, you need to come back with 150 gallons a minute to backwash that correctly. Okay? And I've seen people like, there was a guy over in Yakima that had a set of 48-inch tanks. So they take 190 gallons a minute to backwash. This guy had like 125 gallons a minute of water. That's all he had. And these things have been in there for years, and they never got backwash. I don't know how they were working, but you have to size them so that you have adequate backwash. So basically, those were just a big settling pond. This just gives an idea. We talked about some different sand. This is number 16 here, number 20 here. You can kind of get an idea of the difference in the granule size. The number 20 is going to give you the better level of filtration. You can kind of get a handle on that. So the six.
What does that mean, sawdust?
1630.
What's that mean?
Well, and that's the other thing is different areas of the country have different methods of sizing. So like down where we're at, 16 will be a number 16, and I'm not sure exactly what you guys have up here. It's probably a combination between these two. So a lot of times what we'll do is we'll size it off the effective size of the sand. And so this number 20 would be a 0.45 effective size, and that gets you right to the size of it. And that's based on the gradation and how tight it stays around that one size, okay?
So it's screened twice, well, for the high end and low end, so it's still 16 on one end, 30 on the other. So the sand, the granule,
Can be in between those. Okay.
some places across the border, they use a lot of 2040, which is quite a bit finer, because they have more of a silt and more finer materials in their water that they're trying to. But other than the use that good, we're not really pleased with that too much. It's that fine silt.
Okay. This is just some troubleshooting. Sluggish valves, that would mean that the water generally isn't able to get in there. We talked about that Y strainer for just a second. Since they're run off hydraulic pressure, if they're slow going in, that means you could have a restriction in that Y strainer, something plugged up. Leakage out of actuator, you could have a bad diaphragm. Generally, if I see a diaphragm go bad, it's because somebody installed it backwards. So the diaphragms are marked with the pressure side, and you have to apply it that way. If you put it on backwards, there's a cloth on the outside of the actuator that holds the rubber from blowing through when it's pressurized. If you flip it around, the cloth is on the inside, and there's no way to retain the rubber liner, so it just pushes it right off, makes a blister, and blows it out. So you have to make sure you have the pressure side on the right side. Filter will not stop. You know, we talked just for a second on how it takes hydraulic pressure to operate that valve. And as long as it has hydraulic pressure on it, it's going to stay in backwash. Well, I had an interesting thing. We did a project for the Oakland Zoo over there in California, and I went up there and we got this filter system set up for the elephant pond. And then I flew back down to my office, and I was there for like a week, and these guys called me up and say, "Brian, this filter stopped working." I'm like, oh man. And they didn't know any technical stuff, so I flew back up there. I go into this elephant thing. They had the elephants in this other area, and actually the elephant ended up killing the guy a year later. I don't know why. It was just, that's just something that happened that just stuck in my head. I guess this guy wasn't backwashing his filter enough or something. But what had happened is the thing stopped backwashing, right? Well, somebody went in there and was trying to tidy up everything, and they took that exhaust line off the solenoid and they hose clamped it to the filter leg. Well, so what happens is when the thing's de-energized, the solenoid's trying to let that water out, right, through a tube. Well, when they put the hose clamp on the tube, they plugged it. So once the thing went into backwash, it couldn't get rid of water, it just stayed there. So all it was somebody has a hose clamp. So I was there for about 2 minutes, took the hose clamp off, ran it through a cycle, clipped it so it was nice and clean, and just said, hey, this is it. I got to go home now. So anyways, if it can't get rid of water, it's not going to return out of backwash. Over in Yakima, I had them where they had the cutter bees. I don't know if they have them over here or not. They'll cut like little half circles out of leaves, and they make like nests out of them. These cutter bees went into the bottom of this tubing and just started making their nest in them. So we had to go through and clean out the tubes, you know. Okay. This is the solenoid. I don't know how much you guys want to get into it, but what happens is the water comes in there and stops until it's energized. And then down here, once it's energized, the water comes in, is allowed to go through to the valve actuator, And then this area right here that's dark, that's where the pressurized water is. So as long as it's pressurized, it's got it over there, okay? And it's just a breakdown of the solenoid valve.
And this is real similar between the manufacturers.
Yeah, it's all the same.
It doesn't matter if you have a silver, a blue valve, or a green valve, or an orange valve, they all work basically.
Yeah, yep. So if you have somebody else's, it's gonna be the same troubleshooting technique, the same operation. It's really simple stuff. And this is just showing basically what happens when it goes into backwash. We've already talked about that. This gets energized here. You can see this. And I went through a bunch of them. This starts getting pressurized and it moves this plate over. And that's where that crossover is we talked about, where you got your clean water when it went into backwash. That water goes right around there. And then once it's seated, that's where you got all your dirty water coming out, right there. Then when it de-energizes, it starts returning by getting rid of that water out the solenoid until it's all emptied out and it's all in filtration mode at that point. This is some of the things I've seen. People send them to me, how come my solenoid's not working or my tank's not flushing or whatever. But you know, there's a Y strainer in the end of that manifold that supplies these solenoids, so it needs to be clean. And if it's not, you could end up with something that looks like this. That thing's plugged solid there.
Looks like a manufacturing issue.
Yeah, that's what it is. That's what it is. Well, a lot of times guys will get their Teflon tape stuck in there. Okay, I'm getting the, there's a one of the poly fittings that has a bunch of stuff in it.
Hey, Brian.
Yep.
We're kind of on time for lunch right now.
I got like this one and I'm ready. Okay.
Yeah, we want to find out about the white line.
Oh, here's the white line. Here's the white line. Who can see what's wrong with this picture?
It's probably the backwash.
Mark got it. Do you? See what these guys are doing? They're sucking all the water through here, and that's their pump suction right here, right? Well, then they ran their backwash line right down there. I think I got, let's see. So you can see what's happening. See the water coming in actually is, this is the water coming in. It doesn't look as bad as what they're putting through it all over again. So, anyways. And then, believe it or not, this is one of the most important parts of your filter system, the restrictor valve. Because if you don't have it set right, either it's not going to backwash hard enough, or you're going to lose all your sand. So it's just like a gas pedal in your car. The more you open it, the faster you go. So you just get it set so you have enough water to get rid of the debris in there and just very little sand, okay? And you're good to go. And if the PD goes up and the filters don't want to run, it could be because somebody walked by there and was talking to you and shut the thing off while they were talking to you, because that happens all the time. It's just something to put their hand on. So guys take the wheels off of them and do all kinds of things to prevent that. So anyways. Okay. I'm not going to go with this, some of the other ones we do.
Is that backflow pressure, is that something that you have to change? I asked earlier about the backflushing cycle. And my sediment flow in the river that I pull out, I mean, it changes.
Oh, yeah.
I mean,
Yeah.
in the spring when I got a lot of particular stuff, and then in the summertime, it's, clean as can be. I mean, do I have to, is that backflow pressure gonna have to change to keep it working effectively?
You're looking at it's not the pressure so much if you have the flow, the velocity, because that's what's going to lift the sand bed is the water velocity coming up. So the pressure can be, I mean, at one point you couldn't even care about it, just as long as you had the velocity coming up through there to keep it clean. Some guys will put a pressure sustaining valve on there if it's, if it's an issue. It'll maintain pressure on the filters no matter what happens. If the pressure drops too low, it'll say, okay, I need pressure on the filters to make sure they backwash and I can get that velocity. There's, some of the other controls have a LCD screen on them, and if you were to set the pressure differential a little lower than normal, it would start telling you if the pressure differential switch made it backwash, and that might help you a little bit. But probably it's just a matter of eyeballing it and say, I want to turn this down or turn this up a little bit. It's probably the easiest thing to do. I have a lot of guys that take notes. They just start watching it and they say, well, it backwashed now, the water looks like this. Some guys will put a coffee can underneath the drain line, and they can count how many. It takes about 1 liter of water to fill up a actuator. So, you know, if you had a bucket down there, you could figure out how many times it backwashed since the last time if you wanted to do that. But that way you can start taking your notes and adjust the clock to it. Okay, that's all I have. I'm tired of boring. He says I have to go.
No, I think we got a couple questions.
Oh.
Quick question, would be nice if we went into it now, I don't know if we have time, but maybe some people are gonna ask you about, filtering iron. That's one of the questions that comes up a lot, and I know that you've been, playing around with some of the